An annuity is a regular payment made or received. We most often come across annuities as annuities in arrears as a bank loan, which we can model as a first order difference equation or recurrence equation. T the n plus 1 is the account balance, 1 plus the interest rate as a decimal times the previous term, and then take away your regular payment where T1 is the initial loan. So in the instance given here, we've got an interest per fortnight, so the 9.1 divided by 100 divided by 26.0035. So Tn is the common ratio, 1.0035 times T to the n. Take away the payment that you're making each month, or in this case, each fortnight to the bank. You're starting with a $10,000 loan. So if we scroll down, we'll find out a series of payments that we've made and the account balance at the end of that time. Very nice way of modelling in a tabular formation your bank loan. So in this instance, we've got a $12,000 bank loan being repaid at an annual interest rate of 8%. Interest calculated each month. On the balance outstanding, you have your monthly repayments of $114.68. So to find the monthly interest rate, I is equal to 8 divided by 100 as its percentage, divided by 12, and I end up with 0.06666. I'm rounding it to that point, 7. So if I set up the difference equation, it's the common ratio. In this case, it will be a minus. In this case, and then take from that the 114.68. Now, in this instance, we define the starting point as 0, T0, and that's $12,000. Now, I'll set that up on the calculator as follows. A little word of caution, I had to actually select the n plus 1 A0 option. We tend, outside of this scenario, to work with n plus 1 A1, but in this instance, I've set it up as so. So typing that in, I've set it to be quite a few items, but I will have to reset that now, think of it, to starting at 0. So, starting at 0, and then just running that scenario again. You can see how it's defaulted, and I can go through the various months and find the amount of interest owing. Now I've sneakily set this up to be up to 180 months. 120 months represents 10 years of the loan. I still owe $5,633. You can see here, around about 180, the loan is discharged or paid out. We can also show this graphically. You can see, in this instance, the loan each month decreasing. I'd have to rescale my graph if I actually wanted to see where that ran to at the very end as well. I'll quickly do that. So we'll scale that through to 180. And I'll have to generate my graph again. So you can see the loan running through the 180 months in order to be discharged. So just writing down the balance owing initially after the first month, second month, third month, fourth month, and you can see the graph. It might be a little bit hard to copy that through into your page. Now you've already seen how if we extend the table through to 180 or your sequence through to 180, you'll have paid it off in 180 months. The size of the loan after 10 years you can find by scrolling down. Part G refers to using a suitable financial formula. Now what I've done, I've gone in by the financial part, and And my TVM Solver, 8%, 12,000, 114.68 repayments, future value 0, 12 and 12. And by pressing the N, you can see very, very close to 180 months. Now, obviously, if you haven't covered the financial work, this might be something you look at later.